Okay, page 2 of the notes here. Let's look at Randy's triangle. Consider all the special properties this triangle can have without using any algebra tools. Predict the best name for this triangle. Okay, so I can clearly see the graph of the triangle. We've got what looks to be, I'm going to say this. And at this point, I'd like you to pause the video and do this as well. Give it a couple minutes thought. What do you think is the most specific name we could call that triangle? What special properties does it have? Go ahead and pause. And then after you've had a chance to think about it, maybe you came up with these same ideas. Folks, to me it looks like an isosceles right triangle. Kind of looks like segment RD here is the same length as segment DN. And then it looks like this is a right triangle here. I don't know that for a fact, so I'm going to erase those things, but that's what it looks like to me. Part B, we're asked to think about our answer for part A and answer what is the minimum amount of information that must be true about triangle RND. So what we need to know to prove that it's an isosceles right triangle, we would need the following. Folks, we would need to know the slopes and lengths of segments RD and DN. The slopes will give us information about perpendicular. Why do we need information about perpendicular? That relationship will give us a right triangle. And then the lengths will give us the congruent segments, which gives us an isosceles triangle. Okay, so let's go ahead and do that in part C of the problem. Use the algebra tools to use our algebra tools, the ones that we got in our toolbox, to verify each of the properties you listed in part B. If you need, you may change your prediction of the shape of triangle RND. I don't think we're going to need to change our prediction, but let's go ahead and jump down here and take a look at part C. What I want to do real quick is I like to annotate the coordinates here. D is at 3, 1, because we're going to need to reference these several times, so it's nice to add them to the picture. R is at 1, 7, and then N is 9, 3. So let's start by looking at segment RD. Let's first calculate the slope of RD. Remember, that's delta y over delta x. It's going to be 7 minus 1 over 1 minus 3. That's 6 over negative 2, which is negative 3. Now let's look at the length of segment RD. We're going to take delta x, square it, delta y, square it, add them, and then take the square root. Folks, I don't know if you've ever noticed this before, but if you look back at our calculation for slope, some of those pieces parts show up in the distance formula as well. You just got to be careful and make sure you're not using those quantities after they're simplified. Like when if we were to write it as negative 3 over 1, you can't use those quantities. You have to use it before you simplify. All right, continuing here, 1 minus 3 is negative 2. Negative 2 squared is 4. 7 minus 1 is 6. 6 squared is 36. That gives us square root of 40, which FYI is about 6.325. All right, now let's go ahead and take a look at the next segment, which was DN. The slope of DN first. 3 minus 1 is 2. 9 minus 3 is 6. And that simplifies to 1/3. The length of segment DN. I got the square root of 40 again, which is still about 6.325. Okay, let's just do a quick recap here before we make any conclusions. These two numbers, I can clearly see that those are equal. And then if I take a look at the slopes, I got negative 3 here, and then I got a positive 1/3. And these are opposite reciprocals. So let's go ahead and make some conclusions. Length RD is equal to length DN. That means triangle RND is isosceles. And we also have the relationship RD is going to be perpendicular to segment RN. Why? Because of that opposite reciprocal relationship between the slopes. That means the triangle RND is a right triangle. So our conclusions were correct. Let's now take a look at part D of the problem. We'll go back up here and read it. Part D. Randy wonders if there's anything special about the midpoint of segment RN. Find the midpoint M, then find the lengths RM, DM, and MN. So let's go ahead first and find the midpoint of RN. I'm going to do that work up here. The midpoint of Rn is the average of the x-coordinates, so I have 9 plus 1 over 2, and 7 plus 3 over 2. See, 9 and 1 is 10, 10 divided by 2 is 5, and 7 plus 3 is also 10, divided by 2 is 5. So hey, we got 5 comma 5 there is the midpoint of Rn. Okay, so it says find the midpoint. We check, we've done that. And then find the lengths RM, DM, and MN. So one of them that it asked for is DM, which is going to be that segment length right there. So we need to find that length. I'm going to go ahead and scroll back down so I have some room to do those calculations. First, just to repeat what we did up top, M is the midpoint of segment RN, and we had there 5 comma 5. So now let's find those three lengths. First, RM. 1 minus 5 is negative 4. You square that and you get 16. 7 minus 5 is 2. You square that and you get 4. So what I have here is the square root of 20. I'm not even going to bother converting that to a decimal. I just want to compare these three segment lengths, and I can do that with or without a decimal. Next, let's look at segment DM. 5 minus 3 is 2. 2 squared is 4. 5 minus 1 is 4. 4 squared is 16. Look at that. We got the same value. Square root of 20. Last but not least, let's look at MN. 5 minus 9 is 4. Square that, we get 16. 5 minus 3 is 2. We square that, we get 4. Oh, look at that. We get root 20 again. Conclusion, all three segments are congruent. So I'm going to go back up and add some information to our picture just to make it more complete. We already showed that these two segments, these two side lengths were equal. And now we just showed that these three segments are equal. Why is that interesting? Because that means if I take a isosceles right triangle, I can split it into two additional isosceles triangles. In fact, they end up being isosceles right triangles only. That's a little fun fact for you folks. All right, we're done with 7.3.2. Stay tuned for more in the near future.